This is the first power example problem that you have. It says a record was set for stair climbing when a man ran up the 1,600 steps of the Empire State Building in 10 minutes and 59 seconds. If the height gain of each step was 0.2 meters and the man's mass was 70 kilograms, they want to know what was his average power output during the climb, and they want you to give your answer in both watts and horsepower, hence why we need to know the conversion between the two. Let's take a look at the staircase. So you've got the staircase going up, and whoops, that step didn't look so good. And we know that when you're standing right at the base of the very first step, the force pointing down for you is the force of gravity, and the force up would be your apparent weight. The other thing that we need to know is our change in distance, so our delta R here, which is the same thing as displacement, is in the same direction as our apparent. So we have to be very, very careful with it. Let's figure out how high we actually go. So let's figure out what is our delta R. Our delta R, we know that we have 1,600 steps. Each one of those steps is 0.2 meters. If you multiply those two together, you'll notice that you should end up with 320 meters. Doesn't seem like a lot, but if you remember, a meter is about up to your waist. So 320 of those would be quite a distance. Notice we're not measuring the distance in this direction. We are only measuring the distance from the bottom up to the top. If you remember in the definition of work, when you go left to right, you're not doing any work because that is at a 90-degree angle to the force that you're using in order to climb, which is opposite of the force of gravity. We know that the equation we're going to use in the end is power is equal to work over time, but right now we don't have work. We need to figure out what the work is. Let's figure out what the applied amount of work is, so that goes along with our applied force in order to climb the stairs. This should be equal to the applied force times the change in distance times the cosine of angle. This would be equal to mg. We know that these two should be the same because we're not at an angle, times the change in r times the cosine, and because they're going in the same direction, we would say that that would be 0. This should be equal to 70 multiplied times 10, and then we need to multiply times our distance, which we said was 320, and the cosine of 0 should be equal to 1. So the applied work is 224,000 joules. At this point we can use our power is equal to work over time, so we'll write that again. Our work was 224,000 joules, and the time that we need here is 659 seconds. We got that from the 10 minutes. We had to convert the minutes into seconds, so 10 minutes would be about 600 seconds, and then we have an additional 59 seconds, and that's where we get our 659, and that should be equal to 340 watts. Going back and looking at our conversion, if you do the conversion to horsepower, your answer should be 0.46 horsepower, and that's what he generates when he climbs the stairs. And that is the first of two power example problems.